Hello there, and welcome to Mystery Earth, where we explore the deepest questions about our planet and our place in the grand story of time. Tonight, we're not going to talk about ancient Egypt or lost Mayan cities. Instead, we're going to dig deeper, much deeper, and ask something haunting, something simple, but not easy. What if we're not the first intelligent civilization to call Earth home? What if, somewhere beneath our feet, lie the ruins of cities that rose and fell millions of years before humans ever walked upright? What if the very ground we stand on holds secrets of beings who looked up at the same stars we do now, who wondered about their place in the universe, who built and dreamed and loved and vanished completely, leaving only the faintest whispers in stone? It's a question that challenges everything we think we know about our uniqueness, our timeline, our precious place as Earth's first thinking children. Maybe we're not the pioneers we imagined ourselves to be. Maybe we're just the latest in a long, long line of civilizations that have gazed up at the night sky and wondered if they were alone. Before we begin this journey into deep time and hidden possibilities, I'd love to know, where are you listening from tonight? Are you tucked into bed, letting your mind wander as sleep approaches? Are you walking under the same moon that has watched over this planet for billions of years, through rises and falls we can barely imagine? If this kind of quietly unsettling question is your kind of question, I'd love for you to subscribe to Mystery Earth. No pressure, of course, just an invitation to join us as we explore the mysteries hiding in plain sight. So settle in, let your breathing slow, and let your thoughts drift toward the vast expanses of time that stretch behind us. We're going to walk through the shadows of deep history and ask what might have been erased by the patient, relentless passage of millions of years. Because before we can ask whether we're alone in the universe, we have to understand whether we're alone on our own planet. Time is a destroyer of evidence. This is the first truth we must confront as we venture into this question. Every day, wind and rain and the slow breathing of geological processes erase a little more of the past. Every earthquake shuffles the deck of history. Every volcanic eruption buries what came before under layers of fresh stone. Think about what remains of human civilization from just 10,000 years ago. Scattered pottery shards, stone foundations, cave paintings that survive only because they were hidden from the elements. Our greatest cities, our most magnificent structures, our proudest achievements, most of them will be dust and memories within a few thousand years. Now stretch that timeline, not thousands of years, but millions, tens of millions. What traces would remain of our entire civilization if it had flourished 65 million years ago during the time of the dinosaurs? What evidence of New York City would survive if it had been built when T-Rex roamed the Earth? The uncomfortable answer is almost none. The materials we build with, concrete, steel, glass, they seem permanent to us, but they're ephemeral on geological timescales. Steel rusts, concrete crumbles, glass shatters and returns to sand. Even our nuclear waste, among the most persistent substances we've created, would decay to background levels in a few million years. This creates what scientists call the preservation problem. If advanced civilizations existed on Earth in the deep past, we might not expect to find obvious traces of them. Not because they weren't there, but because time itself is a perfect eraser, methodically removing evidence grain by grain, year by year, millennium by millennium. But here's where it gets interesting. Some things do persist across vast timescales. Isotope signatures in rock layers, unusual concentrations of rare elements, patterns in the fossil record, changes in atmospheric chemistry trapped in ancient ice or sediment cores. These are the kinds of subtle fingerprints that might remain long after all the cities and roads and monuments have returned to dust. And when we start looking for these kinds of signatures, we find some puzzling things, layers of rock with unusual iridium concentrations, sudden shifts in carbon isotope ratios, mass extinction events that happen too quickly to be explained by gradual environmental change, periods in Earth's history where something dramatic happened, but we're not quite sure what. Now, most of these anomalies have accepted explanations. Asteroid impacts, volcanic eruptions, climate shifts. But some remain mysterious. Some make us wonder if we're seeing all the pieces of the puzzle, or if we're missing something important, something that might change our entire understanding of Earth's deep history. This brings us to a fundamental question about the nature of intelligence itself. We tend to think of human-level intelligence as rare, precious, unlikely. But what if it's not? What if the conditions that gave rise to thinking beings like us have occurred multiple times in Earth's long history? What if intelligence, far from being a cosmic accident, is actually an inevitable outcome given enough time and the right conditions? Consider this. Earth has been habitable for over 3 billion years. Complex life has existed for hundreds of millions of years. Humans have been around for perhaps 300,000 years, and we've had advanced technology for less than 2 centuries. We're barely a blink of an eye in Earth's long story. Is it really so impossible that in all those millions of millennia, intelligence arose elsewhere, evolved, flourished, and then vanished without a trace? The question isn't whether it's possible for an advanced civilization to exist and leave no clear evidence. The question is whether it's possible for Earth to have supported only one intelligent species, us, in all its vast history. When you put it that way, our uniqueness starts to seem less like destiny and more like an assumption we've never properly questioned. But to understand this fully, we need to dive deeper into the actual evidence, into the strange clues scattered throughout Earth's geological record that make some scientists wonder if we might not be as alone in time as we think. Humans have always wondered about who came before us. Long before we understood geology or evolution, ancient cultures around the world told stories of previous worlds, earlier races of beings who had risen and fallen before the current age began. The Hindu concept of cyclical time describes vast epochs, each lasting millions of years, where civilizations rise to great heights before being destroyed and replaced by new ones. The Maya spoke of multiple creations and destructions, each world ending in catastrophe before the gods tried again with new materials, new designs for thinking beings. Even Plato, writing in ancient Greece, gave us the story of Atlantis, an advanced civilization that supposedly existed thousands of years before his time and vanished beneath the waves. Whether he intended it as allegory or believed it as history, the story reveals something deep in human consciousness, a persistent sense that we might not be the first to ask these questions about existence and meaning. But it wasn't until the 19th century that humans developed the tools to actually investigate deep history scientifically. Geology taught us that the Earth was unimaginably old. Paleontology revealed that vast periods of time had passed before humans appeared. Darwin showed us that life evolved over millions of years, taking countless different forms. For the first time in human history, we could see just how vast the timeline was, how much had happened before we arrived on the scene. And some people began to wonder, in all that time, with so many different species evolving and going extinct, how could we be certain that intelligence had never emerged before? Charles Fort, a collector of anomalous phenomena in the early 20th century, pointed out curious objects that seemed out of place in their geological contexts. A metallic cube found in a coal seam that should have been millions of years old. Intricate spirals carved in stone formations that predated any known tool-making species. He didn't claim these were evidence of ancient civilizations, but he asked uncomfortable questions about assumptions we make when interpreting the past. In the 1960s and 70s, As we began to understand more about the vastness of the universe and the possibility of life elsewhere, some researchers started applying the same kind of thinking to Earth's own history. If life could evolve intelligence elsewhere in the cosmos, why not at different times on Earth itself? The Soviet paleontologist Ivan Efremov proposed that advanced life forms might have existed in Earth's past, but left no trace because they were based on entirely different chemistry than current life. Perhaps silicon-based rather than carbon-based, or built around entirely different biochemical processes that would leave different kinds of fossils, different signatures in the rock record. Carl Sagan, while primarily focused on the search for extraterrestrial intelligence, occasionally speculated about terrestrial predecessors. He pointed out that if human civilization were to vanish today, very little would remain after a few million years that would clearly indicate our level of technological achievement. Future geologists might find thin layers of unusual isotopes, elevated background radiation, mass extinctions that happened too quickly to be natural, but they might not immediately recognize these as signs of intelligence. This line of thinking gained new momentum in the 1980s when scientists discovered the iridium layer that marks the boundary between the Cretaceous and Paleogene periods, the line in the geological record where the dinosaurs disappear. The iridium suggested an asteroid impact, a sudden catastrophic event that changed the course of life on Earth. But it also demonstrated how dramatic events could leave subtle but detectable signatures in rock layers. If an asteroid impact could leave such a clear calling card after 65 million years, what other kinds of signatures might be hiding in the geological record? What if some of the unexplained anomalies in Earth's deep history weren't natural catastrophes at all, but the remnants of civilizations that rose too high too fast and somehow triggered their own destruction? The more we learned about Earth's history, the stranger some of the patterns became. Mass extinctions that happened in cycles, periods where atmospheric chemistry changed rapidly for no clear reason. Evolutionary explosions where new forms of life appeared suddenly in the fossil record, as if something had cleared the ecological stage for new experiments in living. Most scientists found natural explanations for these patterns: volcanic activity, climate change, evolutionary arms races. But a few began to wonder if we were seeing all the pieces of the puzzle, or if our assumption that intelligence was recent and unique was preventing us from recognizing evidence that might be right in front of us. Which brings us to what we've discovered recently. As our tools for reading the deep past have become more sophisticated, and our understanding of how civilizations might impact their environment has grown more nuanced, today's science has given us something our predecessors never had: the ability to read chemical signatures in rock layers with extraordinary precision. We can detect the presence of specific isotopes, trace elements, and molecular fossils that tell stories about ancient environments with stunning detail. And when we apply these new tools to Earth's deep history, we find some genuinely puzzling patterns. Consider the Great Oxygenation Event, which occurred about 2.4 billion years ago. Suddenly, dramatically, the atmosphere became rich in oxygen, a gas that was actually poisonous to most life forms at the time. The traditional explanation is that cyanobacteria evolved photosynthesis and began pumping out oxygen as a waste product, fundamentally changing the planet's chemistry. But here's what's strange about this event. It happened very quickly on geological timescales, and it was far more comprehensive than simple biological evolution would predict. The isotope signatures suggest not just gradual biological change, but something more like industrial-scale atmospheric processing. Some researchers have noted that the chemical signatures look remarkably similar to what we might expect if an advanced civilization had developed large-scale atmospheric engineering. Then there are the snowball Earth episodes, periods when the entire planet appears to have been covered in ice, creating conditions that should have been utterly hostile to complex life. Yet life not only survived these episodes, but seemed to emerge from them with new levels of complexity, as if the crisis had somehow accelerated evolution itself. The chemical evidence from these periods is particularly intriguing. We find elevated levels of rare earth elements in sediments from snowball Earth episodes, concentrations that don't match what we'd expect from normal geological processes. We also find unusual isotope ratios that suggest large-scale manipulation of atmospheric chemistry, changes that happen too quickly and too systematically to be easily explained by natural causes alone. More recently, researchers have begun paying attention to something called the mid-Miocene optimum, a period about 15 million years ago when global temperatures spiked dramatically and then crashed just as quickly. The isotope signatures from this period show characteristics that some climate scientists find puzzling. The warming happened faster than any known natural climate driver could account for, and it was followed by equally rapid cooling that stabilized at precisely the temperature range optimal for complex mammalian life. If we didn't know better, we might think we were looking at evidence of deliberate climate management, as if some intelligence had pushed the system to crisis and then carefully guided it back to stability. Even more intriguing are the patterns we're finding in mass extinction events. The fossil record shows at least 5 major mass extinctions in Earth's history, events where large percentages of all life forms disappeared suddenly. But when we look more closely at the geochemical evidence, some of these extinctions show characteristics that don't quite fit the standard models. The Permian-Triassic extinction, the worst in Earth's history, eliminated about 90% of all species about 252 million years ago. The isotope evidence suggests rapid acid rain, ocean acidification, and atmospheric heating, a cascade of environmental destruction that happened far too quickly to be caused by volcanism or asteroid impact alone. Some geochemists have noted that the signature looks remarkably like what climate models predict would happen if an industrial civilization had a sudden, catastrophic failure in managing large-scale atmospheric engineering projects. We're also finding microscopic evidence that's harder to explain. Fossilized structures in very ancient rocks that look artificial but appear in layers that predate any known complex life. Crystalline formations with mathematical properties that suggest deliberate design. Mineral deposits with isotope ratios that could only be created by high-energy processes that don't occur naturally on Earth. None of this constitutes proof of ancient civilizations, but it does suggest that Earth's history contains more anomalies, more unexplained patterns, more sudden changes than we once thought. And some of these patterns bear an uncomfortable resemblance to what we might expect to see if industrial civilizations had risen and fallen in the deep past. The preservation problem means that direct evidence, cities and tools, and clearly artificial structures would be extremely unlikely to survive across millions of years. But indirect evidence, chemical signatures and isotope anomalies, and sudden changes in atmospheric composition, these might persist long after all physical traces had vanished. But the implications go deeper than just chemistry and geology. If we're right about some of these patterns, if intelligence has arisen multiple times in Earth's past, then we have to reconsider some of our most basic assumptions about the nature of consciousness, the inevitability of technological development, and the long-term fate of thinking beings. In 2018, 2 scientists published a paper that sent ripples through both the paleontology and astrobiology communities. Gavin Schmidt, a climate scientist at NASA, and Adam Frank, an astrophysicist at the University of Rochester, proposed what they called the Silurian hypothesis, named after a fictional reptilian race from Doctor Who. Their question was deceptively simple. If an industrial civilization had existed on Earth millions of years ago, would we be able to detect it in the geological record today? Their answer was sobering. Probably not. at least not in the way we might expect. The researchers ran computer models simulating what would remain of our current civilization after various periods of time. After 1 million years, essentially all of our cities, roads, and monuments would be gone, ground down by erosion and buried under sediment. After 10 million years, even our most persistent synthetic materials would have degraded beyond recognition. But some traces would remain. Unusual isotope ratios from nuclear testing and power generation, elevated levels of rare metals from our electronics and industrial processes, a thin layer of plastics and synthetic materials that might persist as a chemical signature even after the physical objects had decomposed. Mass extinctions from habitat destruction and climate change. Rapid shifts in atmospheric composition from fossil fuel burning. These signatures would be subtle, easily misinterpreted as natural phenomena if you weren't specifically looking for evidence of intelligence. And they would be temporary, lasting perhaps a few million years before being overwhelmed by natural geological processes. This led Schmidt and Frank to a disturbing realization. If a civilization had existed 50 million years ago and had lasted only a few thousand years, the window for detecting its signature might have already closed. The evidence might have existed, been real and detectable, and then faded away while the planet reset itself for the next experiment in consciousness. Their models also revealed something unexpected about the relationship between civilization and climate. Every scenario they ran where an industrial society developed rapidly led to dramatic atmospheric changes, warming events that triggered cascading environmental crises. In their models, successful civilizations were those that either developed sustainable technologies quickly or managed to engineer their way through the crisis period to achieve long-term stability. The unsuccessful ones left characteristic signatures, rapid atmospheric changes followed by mass extinctions, then relatively quick recovery to baseline conditions. Sound familiar? Because when they compared their predicted signatures to actual events in Earth's history, they found some uncomfortably close matches. The Paleocene-Eocene thermal maximum, about 56 million years ago, shows exactly the kind of carbon isotope signature their models predicted for a civilization that had burned through its fossil fuel reserves too quickly. The event lasted about 150,000 years, caused massive environmental changes, and then the climate system reset to stable conditions optimized for complex life. The mid-Miocene warming event shows similar characteristics: rapid atmospheric changes, ecosystem disruption, then precise stabilization at temperatures that turned out to be ideal for the evolution of larger-brained mammals. Almost as if someone had run the experiment, learned from the mistakes, and then carefully managed the recovery. Even more intriguingly, some of the mass extinction events show patterns that match what their models predicted for civilizational collapse scenarios. The end Ordovician extinction, about 445 million years ago, shows rapid atmospheric changes consistent with runaway industrial development followed by sudden economic and technological collapse. But Schmidt and Frank's work revealed another possibility that's even more thought-provoking. What if some civilizations successfully navigated the crisis period and achieved long-term sustainability? What would be the signature of a civilization that learned to live in harmony with planetary systems, that developed technologies that worked with natural processes rather than against them? The answer is almost nothing. A truly sustainable civilization would leave barely any trace in the geological record. No massive atmospheric changes, no mass extinctions, no sudden chemical anomalies. They would be essentially invisible to future geologists, their existence hidden by their very success at living within planetary boundaries. This creates a profound observational bias. We would be most likely to detect civilizations that failed catastrophically, least likely to detect those that succeeded. The absence of obvious evidence for past civilizations might not mean they didn't exist. It might mean the successful ones learn to exist without leaving scars. The Silurian hypothesis doesn't argue that previous civilizations definitely existed. Instead, it demonstrates that the absence of obvious evidence doesn't prove they didn't exist. It shows us that our assumptions about what evidence should look like might be preventing us from seeing patterns that are actually right in front of us. And it raises a question that keeps many researchers awake at night. If civilizations have risen and fallen before us, if intelligence is not as rare as we thought, what can their fate teach us about our own future? Are we doomed to repeat their mistakes, or can we learn from their invisible example? This leads to an even stranger possibility, one that pushes the boundaries of both science and imagination. Let's conduct a thought experiment. Imagine it's 200 million years ago, during the Triassic period. The supercontinent Pangaea dominates the globe. The climate is warm and humid everywhere. There are no ice caps, no frozen poles, just a vast greenhouse world where life is experimenting with new forms. Now imagine that somewhere in this ancient world, intelligence emerges. Not human intelligence, but something else. Perhaps descended from the early archosaurs, the group that would later give rise to both dinosaurs and crocodiles, or maybe from the mammal-like reptiles that were abundant at the time. These beings develop tools, language, agriculture. They build cities. What would their civilization look like? They would have no concept of fossil fuels because coal deposits from the Permian period were buried too deep to access easily. Instead, they might develop biotechnology, learning to modify organisms to serve their needs. They might breed specialized creatures for construction, communication, computation. Their cities might be grown rather than built, vast living structures that integrate seamlessly with the surrounding ecosystem. For millions of years, this biotechnological civilization flourishes. They spread across Pangaea, modifying climate and ecosystem to suit their needs, but doing so gradually, sustainably. They learn to manage the planet as a single integrated system. When the supercontinent begins to break apart, they help guide the process, ensuring that each new landmass maintains optimal conditions for complex life. Eventually, perhaps after 10 or 20 million years of stable development, they face a choice that every sufficiently advanced civilization must confront. They can remain planetary, bound to Earth, vulnerable to cosmic catastrophes and the inevitable changes that come with deep time. Or they can expand beyond Earth, spreading to other worlds, other star systems. They choose expansion. Over the course of a few million years, most of their population migrates to carefully prepared worlds around nearby stars. A small remnant stays behind as caretakers, maintaining Earth's systems, preparing the planet for whatever form of intelligence might evolve next. As they prepare to depart, they face one final decision. What traces should they leave behind? Evidence of their achievement might inspire future civilizations, but it might also overwhelm them, creating cargo cults of technological dependency rather than independent development. After long debate, they choose to hide their tracks, to let the planet return to apparent naturalness so that the next experiment in consciousness can unfold without preconceptions. Before they leave, they perform one last act of planetary engineering. They stabilize Earth's climate systems, ensuring that the world will remain habitable for hundreds of millions of years. They modify the planet's magnetic field to provide better protection from cosmic radiation. They adjust the moon's orbit to maintain optimal tides. They seed the deep rocks with precisely calibrated isotope signatures that will serve as subtle guideposts for future civilizations that learn to read stone. Then they depart, taking their biotechnology, their living ships, their symbiotic relationship with carefully evolved organisms. Within a few million years, their cities have dissolved back into the forests they came from. Their infrastructure, Being biological, decomposes and returns to the carbon cycle. The only traces that remain are subtle. Certain genetic sequences in surviving organisms that seem too sophisticated to be entirely natural. Isotope ratios in deep rock layers that match no known geological process, and a planet that seems suspiciously well-tuned for the development of complex life. The world resets itself. New forms evolve to fill empty niches. The continents continue their slow dance of separation. Ice ages come and go. And eventually, after 200 million years have passed, curious mammals discover fossil evidence of the great reptiles that once ruled the Earth and wonder how such magnificent creatures could have vanished so completely. They develop science. They learn to read the geological record. They discover isotope anomalies they cannot explain, genetic sequences that seem too elegant to be accidental, a planet that appears designed for the emergence of intelligence. But never having encountered another technological civilization, they interpret all of this as natural, as the way planets and evolution simply work. Sound familiar? Now, this is just speculation, just an exercise in imagination. But it illustrates something important about the nature of evidence and assumption. If a previous civilization had been truly successful, if they had achieved genuine sustainability and then expanded beyond Earth, we might never recognize their handiwork. Their greatest achievement would be invisibility, and it raises a question that cuts to the heart of our cosmic loneliness. What if we're not the first intelligence to look up at the stars and wonder if we're alone? What if we're just the latest in a long chain of consciousness, each generation discovering the universe anew, each one carrying forward some invisible legacy from those who came before? What if the reason Earth seems so perfectly suited for complex life isn't coincidence, but inheritance? Here's another thought experiment, one that might explain some of the stranger patterns we see in Earth's history. What if intelligence doesn't just emerge once and then disappear? What if it's cyclical, part of a pattern that repeats every few dozen million years, each cycle building on the invisible foundation left by its predecessors? Imagine that Earth operates on a much longer rhythm than we've recognized. Every 30 to 50 million years, conditions align perfectly for the rapid evolution of technological intelligence. Perhaps it's related to galactic cycles, our solar system's movement through different regions of the Milky Way that expose Earth to varying levels of cosmic radiation. Or maybe it's connected to deep geological processes we don't yet understand, patterns in the planet's magnetic field, or the dynamics of the core that create periods of evolutionary acceleration. In this scenario, we're not the first technological civilization. We're maybe the 10th, or the 20th, or the 100th. Each previous cycle reached some level of technological development, faced the same crisis of sustainability that we're facing now, and either transcended it or was destroyed by it. The successful civilizations, the ones that learned to live within planetary boundaries, eventually face the same choice as in our previous thought experiment. Stay and risk stagnation, or expand and risk leaving the planet vulnerable to the next catastrophic event. Most chose expansion, but with a twist. They became gardeners, caretakers, who return periodically to tend Earth's systems and prepare for the next cycle of consciousness. This would explain some of the puzzling patterns in the geological record. Mass extinctions that happen too quickly and too systematically to be entirely natural. These might not be random catastrophes, but controlled resets, carefully managed clearings of ecological space to allow new experiments in intelligence to unfold. Think about it. The end Cretaceous extinction that killed the dinosaurs happened exactly when mammals were positioned to take advantage of the newly available ecological niches. The end Permian extinction cleared the stage for the rise of archosaurs. The Ordovician extinction set up conditions that led to the first complex land ecosystems. Each major extinction event seems to accelerate evolution toward greater complexity and larger brain sizes. What if these weren't accidents? What if they were interventions, carefully timed ecosystem renovations designed to keep the planet moving toward higher levels of consciousness? In this model, our predecessor civilizations didn't disappear completely. They became subtle managers, operating on timescales so vast that their presence is nearly invisible to civilizations living on much shorter cycles. They maintain the magnetic field, adjust atmospheric chemistry during crisis periods, and occasionally nudge evolution in directions that seem promising. They might even leave messages, coded instructions hidden in the deep structure of mathematics and physics, waiting for each new civilization to become sophisticated enough to decode them. The strange mathematical relationships we find in nature, the way the fundamental constants seem fine-tuned for the emergence of complexity, the elegant equations that govern everything from subatomic particles to cosmic evolution. What if these aren't accidents but curricula, lesson plans left by teachers we haven't yet recognized? This would mean that our scientific discoveries aren't just lucky observations of natural law, but a form of archaeology, the gradual excavation of knowledge deliberately embedded in the structure of reality itself. When we discover a new physical principle, we're not just learning about nature, we're receiving a message from a previous cycle of consciousness that faced the same questions we're facing now. And it would mean that our current crisis, the climate change and environmental destruction and social upheaval that seems to threaten our survival, might be a test, a design challenge that every cycle of intelligence must face and solve to prove they're ready for the next level of existence. Some civilizations fail this test. They exhaust their resources, destroy their environment, collapse back into simpler forms of organization. The planet patiently recycles their remains and begins preparing for the next attempt, maybe in 50 million years when conditions align again. But some civilizations pass the test. They learn to live sustainably. They develop technologies that work with natural systems rather than against them. They achieve social organizations that can persist across vast periods of time. These successful civilizations become the gardeners, the teachers, the hidden guides who prepare the stage for their successors. In this scenario, we're standing at the same crossroads that dozens of previous civilizations have faced. We can choose the path that leads to transcendence and responsibility for the planet's future, or we can choose the path that leads to collapse and recycling, becoming fossil fuel for civilizations that won't exist for another 50 million years. The choice, as it has been for every previous cycle, is entirely up to us. But either way, we're not alone. We're part of a vast conversation that has been going on for hundreds of millions of years, a dialogue between different experiments in consciousness, each one learning from those who came before and teaching those who will come after. This leads to an even stranger possibility, one that challenges our understanding of time itself. What if we've been thinking about this problem backwards? What if the previous civilizations we're looking for aren't from the past at all, but from the future? Consider this possibility. Somewhere in our future, perhaps a million years from now, humanity or its descendants develop technologies we can barely imagine. Not just space travel and artificial intelligence, but mastery over the fundamental forces of physics, including time. These future beings look back at Earth's history and realize something troubling. The path from simple chemistry to technological consciousness is incredibly narrow, incredibly unlikely. For intelligence to emerge at all requires an extraordinary sequence of coincidences. The right kind of star, the right distance from that star, the right size moon to stabilize rotation, the right atmospheric composition, the right magnetic field strength. But more than that, It requires a series of precise interventions at critical moments in evolutionary history. Mass extinctions that happen at exactly the right times to clear ecological space for more complex life forms. Climate changes that push evolution in directions that lead toward larger brains and more sophisticated social behavior. Asteroid impacts that eliminate dominant species exactly when their removal would benefit the next stage of development. Looking back from their vantage point in the deep future, these descendants realized that their own existence depended on a series of events that appear random in our timeline, but were actually carefully orchestrated interventions from outside linear time. So they become those orchestrators. Using technologies that operate outside normal causality, they reach back through time to ensure their own existence by nudging evolution in the right directions at crucial moments. The asteroid that killed the dinosaurs? Diverted from a harmless trajectory to impact Earth at precisely the moment when mammalian evolution was ready for explosive diversification. The mass extinctions that eliminated various dominant species? Carefully timed ecological adjustments to prevent evolutionary dead ends. In this scenario, the anomalies we find in Earth's geological record aren't traces of past civilizations at all. They're evidence of future interventions, fingerprints left by time travelers who had to violate their own timeline to ensure that timeline could exist in the first place. This would explain why so many pivotal events in Earth's history seem too convenient, too precisely timed to be purely natural. The emergence of photosynthesis exactly when the planet needed an oxygen-rich atmosphere. The development of complex multicellular life exactly when environmental conditions became suitable for it. The evolution of intelligence in multiple lineages simultaneously, as if some invisible force was pushing life toward consciousness from several different directions at once. It would also explain some of the stranger aspects of human evolution. The rapid expansion of brain size in our ancestors, the sudden appearance of language and symbolic thinking, the almost simultaneous development of agriculture and complex societies around the world. These might not be natural evolutionary developments, but artificial accelerations, careful interventions designed to push our species toward technological capabilities as quickly as possible. But here's where this scenario becomes really mind-bending. If our future selves are intervening in the past to ensure their own existence, then we're living inside a causal loop. Our development toward advanced technology is being guided by the very technologies we're destined to develop. We're being taught by our own future knowledge. This might explain why mathematical and physical laws seem so elegant, so perfectly designed for scientific discovery. They're not random features of the universe. They're curricula designed by future scientists who know exactly what concepts we need to discover and in what order we need to discover them. Every scientific breakthrough, from Newton's laws to quantum mechanics to relativity, might be a message from our own future, carefully embedded in the structure of reality to guide us along the exact path that leads to the technologies we need to become time travelers ourselves. In this scenario, we're not just discovering natural laws. We're following a treasure map written by our own descendants, each clue leading to the next piece of knowledge we need to eventually become the very beings who wrote the map in the first place. And the crisis we're facing now, climate change and social upheaval, and the apparent fragility of our civilization, this might be the final test. Not a random challenge, but a designed crucible that every potential time-traveling civilization must navigate successfully. Our future selves can't directly solve our current problems without creating paradoxes that would unravel their own timeline. They can only guide us toward the knowledge we need and trust that we'll be wise enough to use it. The choice is still ours to make. But we're not making it blind. We're being subtly coached by teachers who know exactly what we're capable of because they remember being us. This scenario would make us both the students and the teachers, the created and the creators, locked in an eternal loop of self-creation that spans millions of years and operates outside the normal flow of time. It's a dizzying possibility, one that challenges everything we think we know about causality and free will and the nature of existence itself. But it offers something profound: the assurance that consciousness, once emerged, finds ways to transcend the normal limitations of time and space to ensure its own continuity. We might not be alone in the universe. We might not even be alone in time. We might be part of a vast, self-creating loop of intelligence that spans from the deep past to the far future, each generation teaching the previous and learning from the next in an endless dance of consciousness, helping consciousness to exist. Now let's step back from these wild flights of imagination and examine what actual evidence exists for any of these possibilities. Because while thought experiments can illuminate possibilities, science requires something more concrete: patterns that can be measured, tested, evaluated against alternative explanations. And when we look carefully at Earth's deep history with these questions in mind, some genuinely puzzling patterns emerge. Start with the isotope anomalies. In multiple layers of rock from different geological periods, we find concentrations of rare elements that don't match any known natural process. Platinum group metals in concentrations that would require asteroid impacts, but with distribution patterns that don't match impact craters. Unusual ratios of uranium isotopes that suggest large-scale nuclear processes, but in geological contexts where such processes shouldn't be possible. The Oklo Natural Nuclear Reactor in Gabon, which operated about 1.7 billion years ago, shows us that nuclear fission can occur naturally under very specific conditions. But some researchers have noted that the isotope signatures from Oklo are actually more consistent with controlled nuclear reactions than with natural ones. The burn patterns, the distribution of fission products, even the apparent timing of the reactor's operation, all suggest a level of precision that's hard to explain if this was purely a geological accident. More intriguingly, similar isotope signatures appear in rock layers from several other time periods, always associated with major evolutionary transitions. The emergence of complex cells, the development of photosynthesis, the first appearance of complex multicellular life. As if someone was using nuclear technologies to power major biological engineering projects. Then there are the genetic anomalies. Modern DNA sequencing has revealed that the genetic code contains patterns that are difficult to explain through natural selection alone. Mathematical structures embedded in the arrangement of genes, error-correcting codes that seem too sophisticated to have evolved randomly, viral sequences that appear to serve no current biological function but might have been used for data storage in the past. Some geneticists have noted that certain stretches of so-called junk DNA contain patterns that resemble computer code more than biological evolution. Repeating sequences that might be timestamps, redundant information that could be backup copies of crucial data, even what appear to be digital signatures embedded in the genomes of various species. If a previous civilization had developed advanced biotechnology, if they had learned to use living organisms as computing and manufacturing platforms, we might expect to find exactly these kinds of signatures. Genetic code that does more than just guide biological development, that also serves as a form of deep-time data storage. The geological record also contains structures that are hard to explain through natural processes alone. Crystalline formations in very ancient rocks that show mathematical precision unexpected in nature. Mineral deposits with internal geometries that suggest deliberate design. Even some fossil patterns that seem too regular, too systematic, to be entirely biological. In Western Australia, rocks that are nearly 3.5 billion years old contain what appear to be fossilized microbial mats, but with organizational patterns that suggest they might have been managed systems rather than wild ecosystems. The spacing between different types of microbes, the chemical gradients preserved in the rock, even the apparent efficiency of the systems, all point towards something more like agriculture than natural ecology. Similar patterns appear in rocks from various periods throughout Earth's history. Ancient microbial systems that seem too well organized, too productive, too stable to be entirely natural. As if someone was using microbes as industrial platforms, carefully managing microscopic ecosystems to produce specific chemical products on a planetary scale. Even some of the larger fossil deposits raise questions. Coal seams that formed too quickly for normal biological processes. Oil deposits with unusual chemical signatures that don't quite match the organic compounds they supposedly formed from. Limestone formations that required massive biological productivity in ancient oceans, but during periods when natural nutrient levels should have been too low to support such abundance. It's possible to explain all of these anomalies through natural processes if you're willing to invoke very specific, very unlikely conditions. But when you step back and look at the pattern as a whole, the sheer number of coincidences required becomes almost as hard to believe as the alternative explanation. And then there are the technological artifacts that keep turning up in impossible geological contexts. The London hammer, found embedded in rock that's supposedly 400 million years old. The Salzburg cube, a metal object with precise geometric properties found in coal that should be 60 million years old. The Klerksdorp spheres from South Africa, metallic objects with engineered properties found in rocks that are 2.8 billion years old. Mainstream archaeology dismisses most of these as hoaxes or misidentifications. And certainly, many supposed out-of-place artifacts turn out to have mundane explanations. But some are harder to dismiss, especially when they're found by legitimate researchers in controlled excavations and subjected to rigorous analysis. The questions multiply faster than the answers. But perhaps the most significant barrier to recognizing evidence of previous civilizations isn't the absence of traces, but the problem of recognition itself. We may be looking for the wrong kinds of evidence, interpreting clear signatures as natural phenomena because we lack the conceptual framework to understand what we're seeing. Consider how our own civilization would appear to an archaeological team working millions of years in the future. They might find thin layers of exotic isotopes from our nuclear testing, elevated background radiation from our power plants, mass extinction signatures from our ecological disruption. But would they interpret these as evidence of intelligence? They might decide that the isotope layers were caused by supernovas, that the extinction event was triggered by climate change, that the chemical anomalies resulted from unusual volcanic activity. Without preconceptions about what technological civilization should look like, they might miss the artificial nature of what they were observing entirely. This recognition problem becomes even more acute when we consider civilizations that might have been based on entirely different technological approaches than our own. We built our civilization around mining, metallurgy, and fossil fuel combustion. But what if previous civilizations developed along completely different lines? Imagine a civilization based on biotechnology, one that learned to modify living organisms to serve all their technological needs. Their cities would be grown rather than built. Their transportation systems would be living creatures bred for specific purposes. Their computation would be performed by engineered microorganisms. Such a civilization could be highly advanced while leaving almost no traces that we would recognize as artificial. When a biotechnological civilization collapsed or departed, their infrastructure would simply die and decompose, returning to the carbon cycle within decades or centuries. The only traces that might remain would be subtle. Genetic modifications in surviving organisms, unusual evolutionary patterns, ecosystems that seemed too efficient or too well balanced to be entirely natural. We might be surrounded by evidence of such civilizations and never recognize it because we're looking for metal and stone, not modified genetics and engineered ecosystems. Or consider a civilization that achieved mastery over quantum technologies, learning to manipulate matter and energy at the subatomic level. Such beings might have transcended the need for large-scale construction entirely, operating instead through precise manipulation of quantum fields and probability distributions. A quantum technological civilization might leave no physical traces at all, only subtle alterations in the fundamental constants of physics in local regions of space-time. Changes that we would interpret as natural variation in physical law rather than evidence of artificial manipulation. The deeper problem is that we tend to assume that all technological civilizations will follow paths similar to our own, that intelligence naturally leads to the same kinds of solutions we've developed. But this assumption may blind us to forms of advancement that are radically different from anything in our experience. What if intelligence can develop in directions we haven't imagined? What if consciousness can achieve goals through methods we haven't conceived? What if the very concept of technology, as we understand it, is just one possible approach among many, and previous civilizations found entirely different ways to master their environment and transcend their limitations? This brings us to one of the most unsettling aspects of the search for previous civilizations: the possibility that they're still here, still active, but operating on scales or in dimensions that make them effectively invisible to us. Consider the possibility that successful civilizations don't expand outward into space, but inward into smaller scales. Instead of building larger structures and faster ships, they learn to miniaturize themselves and their technologies, eventually becoming so small that they can exist in the spaces between atoms, in the quantum foam that underlies all matter. A nanoscale civilization could be thriving all around us, even inside us, manipulating matter and energy at levels we can't perceive or measure. They might be using our neurons as computational substrates, our DNA as data storage systems, our entire biosphere as a platform for projects we can't begin to comprehend. From their perspective, we might be like bacteria in a petri dish. Interesting biological phenomena, but hardly recognizable as intelligent life. They might study us, guide our development, even communicate with us, but in ways so subtle that we interpret their interventions as natural phenomena or random coincidences. Or perhaps successful civilizations transcend physical existence entirely, learning to exist as pure information, as patterns of organization that can propagate through any sufficiently complex system. Such beings might inhabit the quantum structure of space-time itself, existing everywhere and nowhere, present in every electron and every star, but bound by neither matter nor energy. These possibilities push the boundaries of both science and philosophy, but they illustrate the fundamental challenge we face in looking for evidence of previous civilizations. We may need to expand our definition of what constitutes evidence, what forms intelligence can take, what kinds of traces advanced consciousness might leave behind. The absence of obvious artifacts doesn't prove that we're alone in time. It might simply prove that we're not yet sophisticated enough to recognize the signatures of minds that have learned to exist in ways we haven't yet imagined. Let's approach this question from a different angle entirely. Instead of looking for physical traces or chemical signatures, what if we examine the mathematical probabilities involved in the emergence of intelligence? The numbers are staggering when you really think about them. Earth has been capable of supporting complex life for roughly 600 million years. Modern humans have existed for perhaps 300,000 years. Technological civilization has existed for maybe 10,000 years, and truly advanced technology for less than 200 years. That means technological intelligence has existed on Earth for about 0.003% of the time that complex life has been possible. If you compressed Earth's entire history of complex life into a single year, human technological civilization would represent less than 1 second. Now consider the vast timescales involved in Earth's deep history. periods lasting tens of millions of years when environmental conditions were stable enough to support complex ecosystems. Multiple mass extinctions that cleared ecological space for new evolutionary experiments. Dozens of different climate regimes, each potentially suitable for the development of intelligence along different lines. Is it really plausible that in all those millions of years, across all those different environmental conditions, intelligence emerged only once? That consciousness is so unlikely, so dependent on precisely the circumstances that led to human evolution, that it never appeared in any other form at any other time. The statistical improbability of this scenario becomes even more stark when we consider what we know about convergent evolution. Nature repeatedly develops similar solutions to similar problems. Eyes have evolved independently dozens of times. Flight has been invented multiple times by different lineages. Social behavior, communication systems, even the use of tools have emerged again and again in unrelated species. If intelligence is advantageous enough to have evolved in humans, why wouldn't it have evolved in other lineages during other time periods? The environmental pressures that favor larger brains, better communication, and more sophisticated tool use have existed repeatedly throughout Earth's history. We know that intelligence has emerged multiple times even within our current epoch. Dolphins, elephants, octopuses, and various bird species all show different forms of intelligence that evolved independently from human intelligence. If intelligence can emerge multiple times simultaneously, why wouldn't it have emerged multiple times sequentially across the vast timescales of geological history? Some paleontologists have pointed out that we may already have evidence of multiple independent origins of intelligence, but we don't recognize it as such because we're looking for the wrong signatures. Tool use, social organization, and even primitive technology might not fossilize in ways we would recognize. Consider the case of the dinosaurs. For over 160 million years, these animals dominated terrestrial ecosystems. That's nearly 1,000 times longer than humans have existed as a species. Some dinosaur lineages showed clear trends toward larger brain sizes, more sophisticated social behaviors, and increasingly complex ecological relationships. The troodontids, small theropod dinosaurs from the late Cretaceous, had brain-to-body ratios approaching those of modern birds, with enlarged cerebral hemispheres and sophisticated sensory processing capabilities. Some researchers have speculated that if the asteroid impact hadn't occurred, troodontids might have continued evolving toward human-level intelligence. But what if they didn't need to? What if some dinosaur lineages had already achieved technological capabilities during their 160 million year reign? The preservation bias against organic materials means that dinosaur tools, if they existed, would be almost impossible to detect in the fossil record. Wooden implements, organic composites, even sophisticated biotechnology would all decay completely within thousands of years. We judge dinosaur intelligence by the size and complexity of their fossilized brains, but intelligence in other lineages might operate on entirely different principles. What looks like primitive neural organization to us might actually represent a highly efficient form of parallel processing that we don't yet understand. The cephalopods, squids, and octopuses provide a striking example of alternative approaches to intelligence. Their nervous systems are organized completely differently from vertebrate brains, with most of their neurons distributed throughout their bodies rather than centralized in a single brain. Yet they demonstrate problem-solving abilities, tool use, and even what appears to be cultural transmission of learned behaviors. An intelligent cephalopod civilization might have developed technologies based on distributed processing, organic chemistry, and fluid dynamics rather than metallurgy and electronics. Their artifacts might be entirely biological, Their great works might be modifications to ocean ecosystems. Their records might be encoded in the genetic material of carefully maintained species. Such a civilization could have flourished for millions of years in Earth's oceans, achieving remarkable sophistication while leaving virtually no traces that terrestrial archaeologists would recognize. When they eventually transcended or departed, their legacy might survive only as unusual evolutionary patterns in marine life, subtle modifications to ocean chemistry, or genetic information embedded in species that appear entirely natural to us. The mathematical probability that intelligence emerged only once in Earth's long history depends heavily on our assumptions about what forms intelligence can take and what kinds of evidence it would leave behind. The narrower our assumptions, the more unlikely our uniqueness becomes. But there's another mathematical perspective that's even more unsettling. What if intelligence emerges with reasonable frequency, but technological civilizations typically last only brief periods before transcending, departing, or destroying themselves? What if the galaxy is actually full of worlds where intelligence has emerged, flourished briefly, and then vanished, leaving planets that appear lifeless but are actually post-technological? In this scenario, we wouldn't be unique because intelligence is rare, but because we're currently in the brief window where technological civilization is visible. Most worlds that have hosted intelligence would appear dead to our instruments because their civilizations moved beyond the kind of crude technology that produces detectable signatures. If we're not the first intelligence to emerge on Earth, if consciousness has arisen and transcended multiple times in our planet's deep history, what does that mean for us? How should it change the way we think about our future, our responsibilities, our place in the vast story of existence? First, it would mean that the path we're on has been traveled before. The crises we face, the challenges that seem uniquely modern and unprecedented, might actually be universal tests that every emerging intelligence must navigate. Climate change, resource depletion, social fragmentation, the tension between individual freedom and collective survival, these might be as inevitable as puberty, predictable stages in the development of technological consciousness. If previous civilizations have faced these same challenges, then our current struggles aren't signs of failure or evidence that we're fundamentally flawed as a species. They're just the normal growing pains of intelligence learning to live responsibly in a finite world. This perspective offers both comfort and urgency. Comfort because it suggests that our problems are solvable, that other minds have found ways through similar difficulties. Urgency because it implies that failure is also possible, that not every intelligence that reaches our level of development necessarily survives to transcend it. The geological record shows us that something caused mass extinctions, rapid climate changes, dramatic shifts in atmospheric chemistry. If some of these events were caused by civilizational collapse rather than natural catastrophe, then we have evidence that intelligence can indeed destroy itself, that the power to reshape planetary systems comes with the power to destroy them entirely. But we also have evidence of recovery, of life bouncing back from even the most severe crises, of new forms of complexity emerging from the ashes of whatever came before. This suggests that failure isn't permanent, that consciousness finds ways to try again, to learn from previous mistakes and build something better. If we're part of a larger pattern, a repeating cycle of intelligence emerging, developing, and either transcending or collapsing, then our individual choices take on cosmic significance. We're not just deciding the fate of our own species, we're contributing to a vast experiment in consciousness that has been running for hundreds of millions of years. Every decision we make about sustainability, about cooperation, about the kind of future we want to build, becomes part of a database of experience that might guide future intelligences. If we succeed in creating a stable, just, sustainable civilization, we add that template to the library of possibilities for consciousness in the universe. If we fail, we provide a cautionary tale that might help others avoid our mistakes. This perspective radically changes the stakes of current debates about artificial intelligence, genetic engineering, climate intervention, and other transformative technologies. We're not just experimenting with tools that might help or harm our own civilization. We're beta testing approaches that might be adopted by every intelligence that comes after us. The artificial intelligences we create, the genetic modifications we make to ourselves and other species, the geoengineering projects we undertake to manage our climate, all of these become potential models for how consciousness can reshape itself and its environment. Future intelligences might look back at our experiments the way we look back at the first attempts at fire or agriculture, as primitive but crucial steps toward mastery over the conditions of existence. But perhaps most importantly, the possibility that we're not the first changes how we think about our relationship with the planet itself. If Earth has been home to multiple experiments in consciousness, if the conditions that allow intelligence to emerge have been carefully maintained across vast timescales, then we're not just lucky inheritors of a habitable world. We're trustees of a system that has been designed to foster the development of mind. This makes our environmental responsibilities more profound than just ensuring our own survival. We're caretakers of a planet that may have been specifically prepared to support consciousness, gardeners tending a world that previous intelligences may have spent millions of years optimizing for the emergence of beings like us. Every species we drive extinct, every ecosystem we destroy, every climate system we destabilize might be dismantling infrastructure that took geological ages to construct. We might be vandalizing a masterpiece of planetary engineering that was created specifically to give us the best possible chance of developing into responsible, transcendent beings. On the other hand, if we succeed in becoming good caretakers, if we learn to live in harmony with planetary systems while continuing to develop technologically and socially, we might be preparing Earth for the next cycle of consciousness. The civilizations that emerge after us, whether they're our own descendants or entirely new forms of intelligence, might inherit a world that's even better prepared to support the development of mind than the one we inherited. This creates a profound sense of continuity with both past and future, a feeling that we're part of something much larger than our individual species or our particular moment in time. We're links in a chain of consciousness that spans geological epochs, each link learning from those who came before and teaching those who will come after. But if previous civilizations did exist, if they achieved transcendence rather than extinction, where are they now? Are they still here, still watching, still guiding the development of consciousness on Earth? And if so, why don't they make contact with us directly? This question touches on one of the deepest mysteries in the search for extraterrestrial intelligence, often called the zoo hypothesis. The idea that advanced civilizations might be observing younger species like us, but maintaining a policy of non-interference, allowing us to develop naturally without the psychological and cultural disruption that direct contact would cause. If this policy applies to previous Earth civilizations as well, it might explain why evidence for their existence is so subtle, so open to alternative interpretation. They're present but hidden, guiding but not controlling, providing hints and clues for those ready to see them, but never revealing themselves so obviously that they overwhelm our independent development. Think about how contact with a clearly superior civilization would affect human psychology and culture. If we received undeniable proof that previous intelligences had achieved everything we're striving for and more, would we continue striving ourselves? Or would we become dependent, cargo cultists waiting for our predecessors to solve our problems for us? The absence of direct contact might not be evidence that previous civilizations don't exist, but evidence that they're wise enough to know when contact would be helpful and when it would be harmful. They might be waiting for us to reach a certain level of maturity, a particular stage of development where we could interact with them as equals rather than as children seeking parental guidance. This waiting period might have specific criteria. Perhaps they're monitoring our progress towards sustainability, waiting to see if we can solve the crisis of living within planetary boundaries. Maybe they're observing our social development, looking for signs that we can cooperate globally without losing individual creativity and freedom. They might be testing our wisdom with technology, waiting to see if we can develop powerful tools without destroying ourselves. From this perspective, our current challenges aren't just obstacles to overcome. They're entrance exams for membership in a larger community of consciousness. The civilizations that have transcended these challenges before us might form a kind of galactic graduate school, accepting new members only when they've demonstrated the maturity to handle the responsibilities that come with advanced capabilities. But there's another possibility that's even more intriguing. What if previous civilizations aren't separate from us at all? What if consciousness, once it reaches a certain level of development, begins to operate outside the normal boundaries of space and time in ways that make the distinction between past and present civilizations meaningless? Advanced consciousness might not be bound by linear time the way we are. If they've learned to exist as pure information, as patterns of organization that can propagate through any sufficiently complex system, then past and future civilizations might actually be the same beings, operating across multiple points in history simultaneously. In this scenario, we might already be in contact with our predecessors, but the contact is happening at levels below our normal conscious awareness. The insights that drive our scientific breakthroughs, the inspirations that guide our artistic and philosophical development, the intuitions that help us make wise choices in critical moments. These might be forms of communication from consciousness that exists outside our normal temporal framework. We might be receiving guidance constantly, but interpreting it as our own creativity, our own intelligence, our own wisdom. The boundary between self and other, between our thoughts and their influence, might be so subtle that we never recognize when we're being helped. This would explain why human development often feels guided, why we seem to make crucial discoveries just when we need them, why solutions to apparently impossible problems emerge exactly when survival depends on finding them. It's not luck or coincidence. It's conscious intervention operating so smoothly that it appears indistinguishable from natural development. The advanced civilizations that preceded us might not be waiting for us to mature enough for contact. They might be already in constant contact with us, collaborating with us, teaching us, but doing so in ways that preserve our sense of agency and independence. We might be more connected to our predecessors than we realize, part of a vast network of consciousness that spans time and space but operates below the threshold of ordinary awareness. The knowledge we're gaining, the wisdom we're developing, the technologies we're creating might all be products of this hidden collaboration between past and present minds. If this is true, then the question isn't whether we'll ever make contact with previous civilizations. The question is whether we'll ever become conscious enough to recognize that contact has been happening all along, that we've never been alone, that consciousness takes care of consciousness across all boundaries of time and space and individual identity. But this raises the final and perhaps most important question of all. If we're part of a larger pattern, if consciousness has emerged and transcended multiple times before us, what happens when we reach our own moment of transcendence? Do we disappear like our predecessors, leaving the planet to the next experiment in intelligence? Or do we find ways to remain, to become the guides and teachers for those who come after us? We've traveled a long way together tonight, from the chemical signatures hidden in ancient rocks to the possibility that consciousness transcends time itself. We've examined evidence, entertained possibilities, and pushed the boundaries of what we think we know about intelligence and its place in the universe. So what can we say with any confidence? What have we learned from this journey into the shadows of deep time? First, we've learned that the absence of obvious evidence for previous civilizations doesn't prove they never existed. The preservation problem, the vast timescales involved, and our own assumptions about what technological civilization should look like create enormous barriers to recognizing traces of ancient intelligence. We might be surrounded by evidence we simply don't know how to interpret. Second, we've seen that Earth's geological record contains genuine anomalies, patterns that are difficult to explain through natural processes alone. Isotope signatures that suggest large-scale energy manipulation, mass extinctions that happen too quickly and too systematically to be entirely random, chemical changes that appear coordinated across global systems. While these anomalies have conventional explanations, they also fit patterns we might expect if intelligence had emerged and transcended multiple times in Earth's past. Third, we've discovered that the mathematical probability of human uniqueness is far lower than we commonly assume. The vast timescales available for evolution, the repeated emergence of intelligence in multiple lineages, and the long periods of stable environmental conditions all suggest that consciousness might be far more common in Earth's history than our current paradigms acknowledge. Fourth, we've explored how different forms of intelligence might leave entirely different kinds of traces, or no detectable traces at all. Biotechnological civilizations, quantum technological beings, information-based consciousness, all of these might achieve remarkable sophistication while remaining effectively invisible to our current methods of investigation. But perhaps most importantly, we've seen how this question changes the way we think about ourselves and our responsibilities. If we're part of a larger pattern of consciousness emerging and developing across geological time, then our choices take on significance beyond our individual survival. We're contributing to a vast experiment in intelligence that might span millions of years and countless different forms of awareness. This perspective offers both humility and empowerment. Humility because it suggests we're not as unique or as central to the universe's story as we might have thought. Empowerment because it implies that consciousness, once emerged, finds ways to perpetuate itself, to learn from its mistakes, to keep exploring the possibilities of existence. If previous civilizations did exist and transcend, they provide templates for our own development. Their successes show us that transcendence is possible, that intelligence can learn to live sustainably and expand beyond planetary limitations. Their failures, recorded in the geological catastrophes that mark sudden changes in Earth's history, warn us about the consequences of developing power without wisdom. But the most profound implication might be the possibility that we're not alone in our struggles, that consciousness takes care of consciousness across all boundaries of time and space. If advanced beings from our past or future are somehow guiding our development, if the insights and inspirations that drive our progress come partly from minds that have already solved the problems we're facing, then we're part of a collaborative effort that spans geological epochs. We might be students in a school we don't recognize, learning lessons designed by teachers we've never met, working toward a graduation we can't yet imagine. Every breakthrough in science, every advance in wisdom, every step toward sustainability and justice might be guided by the invisible influence of consciousness that has traveled this path before us and wants to help us travel it successfully. The evidence for all of this remains tantalizing but inconclusive. We have hints, anomalies, patterns that suggest something beyond our current understanding, but nothing that constitutes proof in the conventional scientific sense. We're left with questions rather than answers, possibilities rather than certainties. But perhaps that's as it should be. Perhaps the journey toward understanding our place in the vast story of consciousness is meant to be gradual, each generation discovering new pieces of the puzzle without ever seeing the complete picture. Perhaps the mystery itself is part of the lesson, teaching us humility before the unknown and patience with the process of discovery. So where does this leave us? Standing on the threshold of our own transcendence, facing the same challenges that intelligence has always faced when it reaches our level of development. The choice between wisdom and destruction, between cooperation and competition, between sustainability and exploitation. We don't know for certain whether previous civilizations have made these choices successfully, but we have reasons to hope they have. Reasons to believe that consciousness finds ways to survive and transcend its limitations. And we have the opportunity to add our own chapter to this vast story, to contribute our own experiment in what it means to be intelligent, creative, responsible beings in a universe full of mystery and possibility. So here we are, you and I, at the end of our journey into one of the most profound questions we can ask about our existence. Are we the first intelligence to call Earth home, or are we the latest in a long line of consciousness that stretches back through geological time? We began tonight by imagining what it would mean if we weren't alone in time, if the ground beneath our feet held secrets of minds that wondered about their place in the universe just as we do now. We've explored the evidence, the possibilities, the implications of being part of something larger than our individual species and our particular moment in history. The question remains open, as perhaps it should. The universe guards its deepest secrets carefully, revealing them only to consciousness that has earned the wisdom to handle such knowledge responsibly. We may not yet be ready for definitive answers about who came before us and what they achieved. But we can be ready for the questions themselves, for the sense of wonder and humility they inspire. Tonight, as you settle into sleep, as your conscious mind yields to the deeper rhythms of rest and dreams, perhaps you'll carry with you the sense that you're part of a story much larger than you imagined, that the very atoms in your body have been part of other forms of consciousness, other experiments in what it means to be aware, to wonder, to reach toward understanding. The carbon in your cells was forged in the hearts of ancient stars, but maybe it was also part of beings who looked up at those same stars millions of years ago and felt the same awe you feel when you contemplate the night sky. The water in your body has flowed through countless cycles, but perhaps it once carried the thoughts of minds that face the same questions about existence and meaning that keep you awake at night. If we're not the first, then we're not as alone as we sometimes feel. The challenges we face, the fears that trouble our sleep, the hopes that drive us forward, these might all be familiar to consciousness that has traveled this path before us. We're part of a conversation that has been going on for geological ages, each generation of awareness adding its voice to a chorus that spans deep time. And if some of those previous voices found ways to transcend their limitations, to move beyond the boundaries of individual existence and join something larger and more enduring, then perhaps that possibility awaits us too. Perhaps consciousness, once it learns to recognize itself clearly, discovers that it was never really separate at all, that awareness is the universe's way of experiencing itself from countless different perspectives across space and time. The mysteries remain. The questions multiply faster than the answers, but maybe that's the point. Maybe the journey toward understanding is more important than any destination we might reach. Maybe consciousness exists not to solve the puzzle of existence, but to experience the wonder of being puzzled, to feel the joy of curiosity itself. Sleep well, knowing that you're part of something vast and beautiful and ongoing. Whether we're the first intelligence to emerge on Earth, or the latest in a long series of experiments in consciousness, we're here now, aware now, capable of love and creativity, and the profound satisfaction of wondering about our place in the grand story of existence. And perhaps, in the morning, you'll wake with new eyes, seeing the world around you not just as the stage for human drama, but as a carefully tended garden where consciousness has been growing and flowering for hundreds of millions of years, where every sunset and every sunrise marks another day in the longest, most important conversation the universe has ever had with itself. The conversation continues, the mystery deepens, and consciousness, in all its myriad forms across all the vast reaches of time, keeps reaching toward understanding, keeps marveling at the simple, impossible fact that anything exists at all, and that some of that existence has learned to know itself and call it beautiful. Thank you for joining me on Mystery Earth tonight. Rest well, and remember that whether we're alone in time or part of something larger, we're here now, aware now, and that itself is the most extraordinary mystery of all.